Hello and welcome to the YouTube channel of Rau IAS Study Circle. So, in this video, we are going to discuss the Science and Technology section of the UPSC Civil Services Prelims examination, which was held recently on 16th June 2024. So, we are going to analyze the Science and Technology section. So, first of all, let's divide the syllabus of Science and Technology into its constituent themes. So broadly, we can divide science and technology into these following 6 themes, which are biology and biotechnology, astronomy and space technology, nuclear technology, frontier technology, which can include information and communication technology, nanotechnology, quantum technology, some questions from material science, and some other miscellaneous technologies. And then we have energy technology and defense technology. So this is the broader distribution of the science and technology syllabus. Now let's see that what was the allocation of questions which was asked this year based on these broad themes. So in our first section, which is biology and biotechnology, we were surprised this year that this section, which in the previous years held a major share of questions, and they were really it had only one question this year, and which was also from biology section, right? The question was on nitric oxide. And then in the astronomy and space technology, it had 2 questions, and which is the regular occurrence that 2 or 3 questions are asked from this theme. And then we saw 1 question from the nuclear technology section. From frontier technology, we had 3 questions. The questions were metaverse, hydrogel, and membrane bioreactor, which is an example of wastewater treatment technology. And then this year, there was an increase in the questions from the energy technology. So we saw 4 questions this year, and this was regarding the distributed energy resources, sustainable aviation fuel, fuel cell electric vehicles, and pumped storage, hydropower. And there were 1 question from the defense technology. So in this video, I'm going to discuss 3 questions from the energy technology and 1 question from the astronomy and space technology section. And subsequently, other questions will be discussed by other science faculties of Rau IAS. So let's begin with the set D of our UPSC question paper. There is a question number 67 in the set D, which says that consider the following. The options are battery storage, biomass generators, fuel cells, rooftop solar photovoltaic units. How many of the above are considered distributed energy resources? So in my opinion, this was a simple question. Now this question consists of keyword which is distributed. That is the energy resources which are distributed or decentralized. Now first of all, what are distributed energy sources? See, distributed energy sources are small scale energy production, energy generation, and storage facilities which are located to the end users. Now let's compare them to the thermal power plants, which are centralized energy resources. Or the other examples of centralized energy resources are like thermal power plants, large scale hydropower plants, nuclear power plants. So these technologies, they are located. There is a significant difference between where the energy is produced in centralized energy resources and via the transmission line this energy is distributed to the end consumers. Okay, but what happens in centralized energy resources is that there is a significant transmission loss also. Okay, as we all know that day by day the energy demand in our country is increasing, right? So, and we also need grid stability, we also need reliable power also. Okay, so in this sense, to supplement the centralized energy resources, we can have some decentralized energy resources also in our vicinity. So these decentralized energy resources, first of all, they have no transmission loss or very little transmission loss, right? And the energy can be produced at the point to source also. Okay, so and these sources can be reliable to the consumers also. Okay, and these are certain benefits of these decentralized energy sources. Now based on this information, let's decode that whether how many of the options given here are decentralized or distributed energy resources. Battery storage. We know that at battery storage, batteries can generate electricity and store electricity at the end point. Okay, so generally batteries generate DC, okay, direct current. So this is an example. And biomass generators, yes, biomass can also generate electricity at the point source, say at large farms or within the vicinity of farmers, right? Or wherever there is a presence of biomass, right? So biomass generators is also one example. Fuel cells, this is also one example of distributed energy resources. And then rooftop solar photovoltaic units, it is also an example of distributed energy resources. So what is the answer of this question? The answer is all four, as all of the four options are considered distributed energy resources. Now with this, let's move on to our next MCQ. We will quickly come to question number 92, but before it, let's see question number 97. This question is again a question from the energy technology section, which says that which of the following is the exhaust pipe emission from fuel cell electric vehicles powered by hydrogen? Now see, if you see this PYQ, this is from previous year 2015. UPSC asked a question on fuel cell technology. And now in electric vehicles, in fuel cell electric vehicles, fuel cells are used. So basically this question was regarding the technology which is being used in fuel cell. And this was one of the easiest question in this year's paper, okay? Now, if you have fair idea, if you have solved PYQ, this question was quite doable, right? Now, the question asks that what is the exhaust emission from the fuel cell electric vehicles which are powered by hydrogen? The options are hydrogen peroxide, hydronium, oxygen, and water vapor. We know this answer, but before it, let's see a few points regarding fuel cells. So, what are fuel cells? Fuel cell is an electrochemical device that converts chemical energy into electric energy, right? So, what is the fuel in fuel cells? Generally, the fuel in fuel cells is hydrogen. That's why the most common type of fuel cell is hydrogen fuel cell. So, in these fuel cells, hydrogen is used as fuel, whereas oxygen is used as oxidizer. So this is a simplistic structure of a fuel cell, and it has three components. What are the components? It has two electrodes, anode as well as cathode, and then it has an electrolyte. The electrolyte can be liquid also, and in this fuel cell, the electrolyte is membrane based. Okay, so let's quickly see what is happening in a fuel cell. At the anode side, what is happening? The fuel is going in, that is hydrogen, and this hydrogen is breaking down into its constituent. This hydrogen is breaking down into hydrogen ion as well as electrons. Okay, and now these hydrogen ions, via this electrolyte, they are moving towards this cathode. So what is electrolyte? Electrolyte is any medium which will facilitate the movement of ions, right? So in this particular cell, this polymer electrolyte is facilitating the movement of hydrogen ions towards the cathode. And through an external circuit, we can see that these electrons generated, they move, right? And what is happening at the cathode end? At the cathode end, we can see that oxygen is coming in, and these hydrogen ions from the anode side, they are combining together with electrons, right? And together with this oxygen here. So what is the net reaction? We can see this net reaction is that these hydrogen ion together with electrons and oxygen, they are combining to form electricity. So what kind of electricity is produced by fuel cells? This is direct current, right? Apart from this, what is the byproduct here? The byproduct here is water vapor, right? Heat and water vapor. So this is one example. Fuel cell is one example of non-polluting energy production source. Okay, so let's move on to our question. Now the question says that what is the byproduct or exhaust of fuel cell electric vehicles? So what is the byproduct? The byproduct is water vapor, or option D. With this, let's move on to our next MCQ for the day, UPSC PYQ, and this was question number 98. This question says that recently the term pumped storage hydropower is actually and appropriately discussed in the context of which of the following? Now you have these particular options, right? Now before this, let's see that what is pumped storage hydropower. See, pumped storage hydropower is a kind of large scale energy storage solution. That is, it is utilized to store energy. Now see, understand the context. Government is pushing more towards adopting uh, 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 renewable energy solutions, right? So government is encouraging or facilitating the creation of energy through renewable sources. What are the prominent renewable sources we have? These are solar energy and wind energy, right? But see, there is one problem with these renewable energy resources. What is the problem? The problem is that they are not reliable. That is, if we talk about solar energy production, the energy can only be produced via solar photovoltaic cell when there is sunlight. Okay, so in any cloudy day and when there is no sunlight, say at night, we cannot generate solar electricity. Okay, and then if we talk about wind electricity, similar problem, that whenever there is a windy day, the wind electricity could be produced during that day only. So what about other days, right? So for that, we need to store the surplus energy which is produced via renewable energy sources or via any other sources. If we have surplus energy and if we can store them, then we can utilize that surplus energy when there is more demand for energy or when we cannot produce energy from solar or wind energy. During those days, we can utilize that stored energy. So for that, one solution is by utilizing pumped storage hydropower, right? So what is the basic principle of pumped storage hydropower? The basic principle is that, see, in this, what happens? This pumped storage hydropower is an energy storage solution which is utilizing two reservoirs, which is utilizing the height difference, the altitude difference between two reservoirs. So primarily there are two reservoirs. One is a lower reservoir and there is an upper reservoir which is built at an altitude. Now we all know that when water is stored at an altitude, then there is an enormous potential energy. This is the product of the height. Okay, because of this water which is stored at higher elevation, it has a higher potential energy, right? So what are we doing in this process? Using the excess energy via renewable sources or via any other sources, we are pumping the water from lower reservoir to an upper reservoir, right? And when we need energy, when we need surplus, when we need to use this surplus energy, then what we can do? We can release this water. Then we can release this water from upper reservoirs to lower reservoir, right? So in this process, we all know that how is hydroelectricity produced? This is produced when water falls at turbine and turbine rotates, and in this process we can generate hydroelectricity. So the principle is the same. We are just utilizing the height difference between lower reservoir and upper reservoir, and in this process we can recycle the same water. Nearly the same water can be recycled, okay, and the efficiency is nearly about 80% in this process, okay. So it is one kind of energy storage solution. Now let's come to our MCQ. The MCQ says that this term is discussed in the context of, read the options, irrigation of terraced crop fields, lift irrigation of cereal crops, long duration energy storage, and rainwater harvesting. So what is the correct option? The correct option is long duration energy storage, which is option C, okay, which is option C, long duration energy storage. So now let's move on to an interesting question from the segment Space and Astronomy. Now this question says that, consider the following statements. Statement 1, giant stars live much longer than dwarf stars. Statement 2, compared to dwarf stars, giant stars have a greater rate of nuclear reactions. So we can see that there is some kind of contradiction among these two statements, right? So we will decode it. But first, let us understand that what are some points of difference between giant stars and dwarf stars. Now see, depending upon their mass, first thing, depending upon their mass, dwarf stars are those stars who have mass less than 8 to 10 solar masses, where solar mass is the mass of our sun. And giant stars are those who have mass more than 8 to 10 solar masses, And also the stars can be categorized as dwarf star or giant stars based on their stages in stellar evolution. So which the star which is in early stages of stellar evolution is a dwarf star, and generally giant star is a star which is in the later stages in stellar evolution, right? Now this brings us to the point that what is happening in stars, that is what is the primary process of energy generation or fuel burning in any star. The first thing is that stars primarily they are composed of hydrogen gas, right? And there is a process which is known as nuclear fusion, which is happening at the core of giant stars also and dwarf stars also. Okay, so at the core of both is a star, there is a process called nuclear fusion, in which the hydrogen or the lighter nuclei they are fusing together to form heavier nuclei. That hydrogen is fusing hydrogen nuclei, they are fusing together to form helium, and in this process energy is released in form of gamma rays, right? Now as a question asks that there must be some difference, is there a difference between the nuclear reaction in a giant star and in a dwarf star? So yeah, there is a difference, and what is the reason for it? See, in dwarf stars, the nuclear fusion or the process of generation of energy, it is dominated by the proton-proton cycle. We are not going into detail of this, but this is the proton cycle in which two protons or hydrogen nuclei they are fusing first to form one deuterium, and further a deuterium and one hydrogen nuclei they are fusing to form helium-3, which is an isotope of helium, and then finally helium-3, it is subsequently to helium-3 isotopes they are fusing to form helium nucleus or alpha particle, and this process energy is released. So this is the net reaction that what is happening in any dwarf star. Okay, so this nuclear fusion in any dwarf star is dominated by proton-proton cycle, right? Now see one fact, that these protons, these are positively charged particles. Now when we say that protons are fusing together, so you must understand one thing that these are positively charged particles, right? And we know that like charges they repel each other, right? So there is a huge Coulomb barrier, or there is a huge electrostatic force of repulsion, right? Now in order to overcome this Coulomb barrier, there should be enormous pressure and temperature which is present at the core of stars, right? So because see these stars, owing to their large mass, they have large gravitational field, and then there is a subsequent enormous pressure which fuses these two protons together to form deuterium, and in subsequent process helium, right? So now this process is happening in any dwarf star. But what happens in any giant star? The giant star, the process of carbon, nitrogen and oxygen cycle is more dominant. Why? See, because in any giant star, this is the final reaction. What is happening here? Also hydrogen is fusing to produce helium, but in this process there are certain catalysts like carbon. This process is facilitated by certain catalysts like carbon, nitrogen, oxygen, right? Now if you see the first step of this carbon, nitrogen, oxygen cycle, we see here that this hydrogen nuclei, it is fusing with carbon 12, right? And now we know that as the size of carbon 12 is even bigger, right, as compared to hydrogen or proton, so there would be enormous Coulomb barrier or electrostatic force of repulsion to bring these two atoms together, right? So but this is possible in any giant star. Why? Because of enormous mass and then enormous gravitational field and pressure. So in summation we can say that owing to large size, owing to large gravitational field and large pressure present in the core of a giant star, such CNO cycle is possible there. And there is a difference between proton-proton cycle and this CNO cycle is that this cycle which is happening at the core of giant star, this cycle is fast, as compared to the proton-proton cycle, which is steady. So in simple words, we can say that the nuclear reaction, the rate of nuclear reaction in any dwarf star is less as compared to the rate of reaction which is happening in any giant star, right? So that is the reason that the giant star, it burns up its fuel quickly, and then ultimately the giant star will die in a supernova explosion. Okay, so now let's come to our statements. The statement says that giant star live much longer than dwarf star. So this is incorrect, because giant star, they will spend their fuel faster, and so they are generally short-lived as compared to dwarf stars. Statement 2, compared to dwarf stars, giant star have a greater rate of nuclear reaction. So this is a correct statement. So let's come up to our option. Here the correct answer is option D, as statement 1 is incorrect, but statement 2 is correct. Okay.
Now, looking at question number 86, that is asked on sustainable aviation fuel. Now, sustainable aviation fuel has been in news last year because India started 1% sustainable aviation fuel in our aircrafts. This has been one of the initiatives that have been launched in order to reduce the carbon footprint of our aviation industry, and also to find viable alternatives, green alternatives. Now, there have been questions on biofuels otherwise also in this year's prelims, but in this question particularly, it is on sustainable aviation fuel. So the question is, out of these 4, agriculture residues, corn grain, wastewater treatment sludge, wood mill waste, out of these 4, which of the above can be used as a feedstock for producing sustainable aviation fuel? Now, the sustainable aviation fuel is basically a kind of a biofuel only. It's a kind of a biofuel which happens to be sustainable nature, which is not derived from fossil fuels, but rather derived from biomass. It is derived from biomass. Now, when biomass is being used as a primary feedstock for biofuels, all of you can understand the biomass could be in the form of fat, the biomass could be in the form of carbohydrates, or in the form of proteins. The fat part of the biomass, where it converts into a fuel, we often consider this as biodiesel, right? This is the fat part of the biomass. And when the carbohydrate part of the biomass converts into a fuel, we often consider it as bioethanol, right? So the sustainable aviation fuel is a one of a kind fuel which can be made from biodiesel, or can be also made from can be also used. Bioethanol can also be used as one of the additives. So both biodiesel and bioethanol can be used as one of the primary additives in order to reduce the carbon footprint and improve the overall sustainability of aviation fuel. So when you look at these 4 areas, agriculture residues, of course, this can be used because both protein and carbohydrate, both fats and carbohydrates can be derived from this, and you can convert this into a fuel, right? We have both transesterification, fermentation methods that can be used. Corn grain, yes, of course, corn happens to be a carbohydrate rich food, which is obviously can be transformed into ethanol. Wastewater treatment sludge, wastewater treatment sludge. This is basically the wastewater that has been derived from municipal wastewater, industrial wastewater, and they normally have chemicals which may be having organic properties, and from the sludge we can convert it into any kind of biofuel. It is possible for us to grow wastewater treatment sludge. We can actually derive some kind of biodiesel from the wastewater sludge, and of course the sludge can also be undergo fermentation, and we can obviously create other kinds of biofuels. And then lastly, we have wood mill waste. The wood mill waste mostly contains the wood sawdust, and the sawdust is also supposed to be a good resource for cellulose and hemicellulose, so that can also be broken into some kind of alcohols. So it's not a very difficult question to answer. it's very obvious that all these four ingredients can obviously help in creating any kind of fuel. And for this, the only option that fits in all the four components, it is option C. So the correct answer for this particular question number 86, is option C. I hope you are able to understand. Moving on to the next question. The next question is question number 91, and it says, with reference to the radioisotope thermoelectric generators, RTGs, with reference to radioisotope thermoelectric generators, consider the following statements. The first statement is, RTGs are miniature fission reactors. RTGs are used for powering the onboard systems of spacecrafts, and RTGs can use plutonium-238, which is byproduct of a weapon which is byproduct of a weapons development program, right? Byproduct of weapons development. Now, let me first tell you what do we understand by RTGs. What are radioisotope thermoelectric generators? Now, I have placed this image of RTG. This is a very crude, raw image of RTG. Let me quickly tell you that what is radioisotope thermoelectric generators. See, we all know that when you talk about a radioactive material, there are two ways of harnessing energy from a radioactive material or from a heavy radioactive material, right? The one is by breaking down the nucleus. We call it nuclear fission. We can break down the heavy nucleus into smaller nuclei, and whatever extra energy that was being held in the bigger nucleus, it can be released in the surroundings in the form of nuclear fission energy. This is one way of harnessing energy from a radioisotope, from a heavy radioisotope. But another method of harnessing energy from a heavy radioisotope is by using its natural radioactive decay. Actually, guys, the natural radioactive decay of radioisotopes, it is itself a process through which the unstable heavy nucleus releases its stability in the form of heat, in the form of different types of high energy radiations. So the radioisotope thermoelectric generators, RTGs, they do not primarily work on nuclear fission. They don't require a high speed neutron to break the nucleus and release energy. Rather, RTGs basically use the natural decay process. You can see in both these images, this is the radioactive material at the center, and this radioactive material naturally decays. It naturally releases its instability in the form of heat, in the form of high speed neutrons, in the form of high energy radiations, alpha, beta and gamma particles. And when they release all these energy, these particles, they tend to trigger some kind of reaction, some kind of electricity. They tend to produce some kind of electricity when they fall on a certain plate. So basically, this natural radioactive decay, it naturally releases heat, plus it naturally releases radiation, high energy radiation, and both of them could be a good agent for producing any kind of power. The heat can be used to power up small thermoelectric generators, and the high energy radiation can also power some stronger photons, and eventually they can trigger photoelectric phenomena. So particularly for spacecraft that have been launched not by India has not been able to develop this technique so far, but USA have been harnessing this particular technique since the 1970s. The very famous Voyager spacecraft, right? Both the Voyager 1 and 2, they both were powered by these similar RTGs. In fact, the quite recent New Horizons spacecraft is also powered by the similar technology, RTGs only. So they simply put a radioactive isotope inside inside a canister, and as the radioactive isotope disintegrates, the heat that it releases in order to achieve stability, that is eventually taken and it is converted into electricity. That's why it is called thermoelectric, converting heat into electricity, right? So the first point, although it's a miniature reactor, that's correct, but it does not work on the principle of fission. Fission is not the principle behind the working of RTGs. So the first statement seems to be incorrect, but the second statement seems to be absolutely correct, because yes, spacecrafts has been powered by this RTG reactors. And the third statement is RTGs can use plutonium-238, which is a byproduct of weapon development system. Guys, again, this is also true. Plutonium-238 otherwise is not fissile. It cannot undergo a nuclear chain reaction. But yes, because it is radioactive, it can obviously be converted into energy with the help of RTGs. So yes, plutonium-238 is often used, which is normally produced in the weapon development program. When USA itself was producing weapon grade plutonium-238 eventually came out as one of the byproducts, which essentially powered the RTGs that US had used and have been using since 1970s. So even the third statement seems to be correct, and the answer to this question the most possible and the right answer to this question should be B, 2 and 3. Option 2 and 3 should be the answer, because 1 is obviously incorrect because it does not follow the fission reaction. I hope you are able to understand. Now let us go to the next question. The next question is about, consider the following aircrafts. Number 1 is Rafale, MiG-29, Tejas Mark 1. How many of the above are considered as 5th generation fighter aircraft? Now, many of you might have often heard of this expression, 4th generation fighter aircraft, 4.5 generation fighter aircraft, 5th generation fighter aircraft, and now people are even talking about 6th generation fighter aircraft. Now, what do we really understand by these generations when we talk about? See, although it is not considered to be a very scientific way of defining generations of fighter aircraft, it is just that when the arms race was going on between USA and USSR, they were doing a lot of R&D, research and development in military equipments, in aircraft, fighter aircraft, space equipments. So when this arms race was going on, what was realized was that when USA was developing some new technology of aircrafts, Russia would try to top that technology by creating an even advanced version. So every time this particular expression became a popular expression, that this one is next generation than the Americans ones. The Russians would say that this one is next generation of the American ones. Americans would say that this is the next generation aircraft from the Russian ones. So likewise, this arms race started. Of course, UK as well as France were also essential part of this arms race, but it was mostly between USA and USSR. And because this arms race was going on between these countries, and every time they were trying to top the design of the other opponent country, this expression of first generation, second generation eventually grew out of that. There is no well-defined, specifications anywhere that this would be qualifying as a first generation and the other aircraft would be qualifying as a second generation. So when this became the standard, the most advanced fighter aircrafts today which are in service, I'm saying, that means they have been already deployed with the respective air force, they are 5th generation fighter aircrafts. And it has been found out that 5th generation fighter aircrafts, they happen to be capable as 4th generation, they have all the capability of 4th generation fighter aircraft, but they are slightly better in terms of some new features. It has been added with some additional features. So basically the idea is that first generation fighter aircraft will have the basic features that they will be only able to fly in an ongoing combat. Second generation fighter aircraft will have somewhat better features. They would have better control, they would have better speed, they would be able to go to a slightly higher altitude than the first generation. Third generation fighter aircraft will have even faster speed than the second generation. They can fly at a much greater speed. They can go to a much higher altitude. They can perform multiple functions of dogfighting, of functions as bombers, and multiple other functions also. Some kind of surveillance functions also they can follow. When it comes to third generation, they are also capable of carrying some bigger artillery, some heavier artilleries can also be carried. And then comes fourth generation. Fourth generations are the ones which are not just capable, having all the capabilities of third generation, but they can go even further, and they can touch very high speed faster than the speed of sound. So this is a simple newspaper cutout from Times of India that we have been able to find on the internet, and it very clearly defines what are first generation, second generation, third generation, and fourth generation. So it clearly shows that fourth generations are basically the ones which are having better control systems, and they are also capable of managing all the capabilities of the third generation, but they can go even faster and able to manifest those capabilities even greater. Then we have 4.5 generation, and 4.5 generation, as it shows, that these are the 4.5 generations are the ones that can go even faster than the speed of sound. They are having some capabilities of even escaping from an incoming radar connection and such. Some capabilities, not all the features. They are able to intercept an incoming radar. Suppose if you are flying a 4.5 generation fighter aircraft, and suppose this fighter aircraft enters into the enemy territory, it is able to itself figure out whether the enemy radar has been able to detect it or not, if the enemy is trying to detect them or not. All these things a 4.5 generation aircraft is able to detect. And then comes the 5th generation fighter aircraft. Right now the 5th generation fighter aircrafts are the most advanced in service, and these are those fighter aircrafts which can be easily achieve a supersonic speed, that means a speed faster than the speed of sound, and also are equipped with complete stealth features. Stealth is one of the features that we have extensively talked about in the class also. Stealth basically is called low observation capabilities. That means even if you take a 5th generation fighter aircraft which is having a full-fledged stealth capability into the enemy territory, the enemy will find it very difficult to detect whether whether there is an alien or an enemy aircraft in their own air defense zone. So this basically is having stealth features, and this feature basically outpowers 5th generation fighter aircrafts compared to any other generation which is in service. Now, unfortunately, India so far do not have even a single 5th generation fighter aircraft in its service. Although, according to a lot of different media sources, it is said that India is working. HAL is working on its own 5th generation fighter aircraft. India is working on its own indigenously designed fighter aircraft. But right now, there is no 5th generation fighter aircraft in service of India. Although Russia has been able to claim to release one of the 5th generation fighter aircraft. They call it the Sukhoi Su-57. Then China has also claimed to have developed JF-20, JF-25, which is often considered to have some stealth features. Then America is the first country to come up with their own stealth fighter aircrafts. You can see two of them are mentioned in this also: F-35 Lightning II and F-22 Raptors. These are the two 5th generation fighter aircraft that America has been able to register. So these are the 4 5th generation fighter aircraft that we have been able to get across the world right now. But yes, other countries are working on it. Even Turkey is also working on developing its own 5th generation fighter aircraft. So it's obvious this question is a very factual, very simple question. Rafale, MiG-29, they just marked one. None of them are 5th generation fighter aircraft. The answer is D. None of them are a 5th generation fighter aircraft. I hope all of you are able to understand. It's a simple question though.
Now, this question from set D, numbered 88, is on a very common term that you keep hearing in the context of Web 3.0 applications, called the metaverse. Many headlines have been seen in the past couple of years where the CEOs of the big techs have expressed their own ideas of metaverse. Metaverse is touted to be the future of internet, and in that context, metaverse is something that is often seen in news, and therefore a question is asked. Fairly easy question. You just have to identify the definition of it. That's about it. Which one of the following words or phrases is most appropriately used in order to denote an interoperable network of 3D virtual worlds? That's what metaverse is all about. A little bit about metaverse. As I said, metaverse is touted to be the future of the internet. In that sense, it is really how the internet is going to look like under Web 3.0. A little bit of background to appreciate this. Web 1.0 was the PC internet phase, where I would have to go to a computer, switch on the computer, plug in a wire, and then get on the internet. Very difficult to get on the internet. This is a time in which my physical world was more important than my virtual world. In the era of social networking, and this is called Web 1.0, primarily the internet was used for web browsing, looking for information, at the max some emails, and also maybe some chat applications. That about it. But you were very anonymous under Web 1.0. Now the transition has happened early 2010 or 2008 onwards, with the increase in communication speeds in communication technology also, but many other technologies that drove the social networking era, which is what Web 2.0 is all about, in which you are basically it's much easier to get on the internet just switching on your phone, or whenever the phone is on, you are on the internet. All you have to do in order to get out of the internet is just switch off your phone. That is Web 2.0, in which the physical world and the virtual world is as important as each other. That is Web 2.0. Okay, Web 2.0 applications are your Instagram, Facebook, and so on and so forth, where you are not only consuming content, but you're also producer of content. That's Web 2.0. The future of internet, at least the vision for future of internet, is touted to be the metaverse, in which you basically live in the internet. That is why metaverse is also called as what is called as embodied internet. Embodied internet, and this will be driven, okay, and primarily, please understand, your experience of the internet is becoming more and more immersive. More and more immersive meaning more and more close to your physical reality. Web 1.0 was very unlike your physical reality. In your physical reality, you deal with 3D objects, 3D people, and 3D surround sound, and so on and so forth. Web 1.0 was just a web page, very away from your physical reality, and therefore not a very immersive experience. Even today, you see 2D screens. For example, this video, you're seeing a 2D screen. Again, more immersive than this, but less immersive, meaning it's not very similar to what you experience in the physical reality. And the future internet would would be an immersive experience, in the sense that you embody yourself in the internet, you live in the internet, and therefore this will be driven by a 3D virtual world. So any web page you would get into, or any social networking site you would want to get into, or WhatsApp messengers, and so on and so forth, you will experience a 3D virtual world. So you need a VR headset. Okay, in fact, many technologies, a suite of technologies are really driving the build up of this metaverse. We don't know what metaverse is. Everybody has their own idea of metaverse, but metaverse essentially is, one way of looking at it, is embodied internet driven by these technologies. And to make it immersive, you have your VR headsets, AR, and so on and so forth. To make this as real time as possible, we definitely need faster computing methods, high speed communication networks, and so on and so forth. 5G and onwards, you will basically see the use of 5G and all of this in metaverse. It should not be very difficult to appreciate this. In fact, this is the kind. So this is how your classroom may look like, or an office experience, office meeting may look like. That is why metaverse is called as the embodied internet. But in addition, I don't want to define metaverse, but you can see these kind of headlines in which many cities, in fact, a whole country, Tuvalu, which is basically a Pacific island country, it has put itself on the metaverse, meaning it has made a virtual world of Tuvalu, the country, or many of these cities, Seoul or even Istanbul, for that matter, in which they have put a virtual world of the city, and they start selling. In fact, the Web 3.0 applications are going to make it possible for not only exchange of information, but exchange of assets also. So you can represent assets on the internet, which is not possible right now, but this is going to be guided by the NFTs. That is what the significance of your non-fungible tokens driven by blockchain are, really. And this is, in fact, this is what is being done in Istanbul, meaning you don't have to physically be there. Today, if you want to buy and sell land, you have to be physically be there. But driven by NFTs, Web 3.0 is going to make it possible to buy and sell land virtually. So internet is not going to only be used for exchange of information, but also exchange of assets, and these value carriers are NFTs. And that is why, okay, if you see the question, it exactly talks about that. So it includes both of these aspects: an interoperable network of 3D virtual worlds that can be accessed simultaneously meaning high speeds, and therefore it's going to be a real-time experience by millions of users who can exert property rights over virtual items. So your physical world is going to be virtualized. So when I'm digitizing the physical world, how am I going to basically deal with exchange of these assets, NFTs? And that is exactly what the last line is also talking about. Fairly simple question. You don't really have to know so much details in order to do this, but no harm in knowing the details. So metaverse, this is answer option C is the answer. Now coming to the next question, 93 on set D. Which one of the following is synthesized in human body that dilates blood vessels and increase blood flow? Now, one very important area that civil services exams always focus on is human health, and more importantly, in the recent times, the non-communicable diseases have become very significant, particularly the cardiovascular health. And nitric oxide, in fact, is called as the miracle molecule. Even if you did not know the mechanism of nitric oxide, we'll talk about it in a little while, but you often hear of miracle molecule. In fact, 1998, the Nobel Prize was given on, was conferred upon on the understanding of the working of the blood vessels. To appreciate this, a little more details. When you talk about the circulatory system, of course, the circulatory system is very important in order to transport the nutrients for every cell of the body. But because fundamentally, please understand, all life is united at cell level, which is essentially doing, all cells are essentially doing cellular respiration. And in order for the cellular respiration to happen, they need nutrients, and complex organisms like humans, we have developed a mechanism to transport these nutrients to every cell of the body. Body is just a collection of different types of cells, and about human body has about uh, 200 to 300 different types of cells. That being said, so therefore, sending of nutrients or transport of nutrients is a very important function your circulatory system is essentially doing. And when the blood is pumped by the heart, okay, and as it enters those tubes, and blood, as you very well know, is carried to every part of the body, every cell of the body, through small tubes. At some places it is bigger, and some places these tubes are very, very small. The small tubes are called capillaries, which are closer to the cell, and the bigger tubes, of course, aorta or arteries are the biggest tubes that you have, is close to the heart. And in this process, and there's a very it's a coordinated mechanism. All of these organs in your body are working in sync with each other, in tandem with each other, in order for this process to happen smoothly. And one such process is how these blood vessels, these tubes, and the pumping organ, the heart, is coordinating with each other in order for this blood to flow smoothly. And in that sense, your blood vessels are made up of, again, blood vessels are blood vessels are made up of muscles inside its inner walls, and these muscles tend to expand or widen, or what we call as dilate fancily, when the blood is gushing through in. Because when the blood gushes, please understand, the pressure of the blood is increasing, and high blood pressure is going to be harmful on the pumping organ. As a result, your blood pipes or blood vessels have to widen so that the blood moves smoothly to different parts of the body. And the inner lining of these vessels have these messenger molecules called nitric oxide, which essentially signals the muscles to widen or relax, and therefore making these blood vessels widen. That is why nitric oxide, which is a pollutant also, was figured out to be a miracle molecule in a good cardiovascular health. And as you age, your body's ability to produce this nitric oxide decreases. As a result, there are supplements that are being suggested by the doctors. So this is okay. This is what, in fact, nitric oxide production is what is improved when you have certain kind of food like spinach, green leafy vegetables, or for that matter, even citrus fruits, orange, lemon, and so on and so forth. Okay, A is the answer. Fairly easy question. If you have heard about it, you should have heard about it, particularly in the context of increasing concern of cardiovascular diseases as a result of lifestyle changes. So A is the answer for this question. Now, the next question I want to take up is question number 94. Fairly easy question again. So, anything about remote sensing, whenever you hear about remote sensing, if you understand the basic principles of remote sensing, is fairly easy to answer this question. In how many of the above activities can the radars be used? Radar is what? Radio amplification, detection, and ranging. Basically, what you're doing in radars is you're beaming a flash of radio light. It is being reflected by the object, and that reflected light is what you're sensing and thereby understanding some of the characteristics of these objects. And this is what is the basic principle of remote sensing. Remote sensing basically works on the principle of how light interacts with the objects. And in that sense, when we choose different electromagnetic waves, light is nothing but electromagnetic wave, all different types of light. It depends on when you choose a certain kind of electromagnetic wave, you choose different electromagnetic waves to study different characteristics of an object, to see the size, shape, and color of an object. You basically, as we all know, in our common experience or intuitive experience, visible light is what we basically use. You are basically seeing me in this video because I am reflecting the molecules on my body, the atoms on my body is reflecting the light that is coming from this tube light. And therefore, if I switch off this tube light, you won't be able to see me because there is no light that is falling on me for me to reflect it back. This is the best example of remote sensing. But what light do we choose depends on what characteristic I want to understand. So therefore, it's all about how light interacts with the objects. And when I look at how light interacts with the object, different electromagnetic waves interact with the objects. Although there are many different ways light interacts with the objects, one very important way is, or one very important factor for this light to interact with objects is the size of the wave and size of the particle. Please understand this, if size of the wave and size of the particle is comparable to each other, they can interact. It's like taking two billiard balls and hitting with each other. But if I took a larger ball, say size of this building, and hit it with a small billiard ball, it will roll over the billiard ball. As a result, these large waves, radio waves as we know, are large waves. We never use these waves, especially because radio waves, you see, 1 meter to about 1 meter to kilometers, tens of kilometers, hundreds of kilometers also. But for simplicity, we take about 1 meter to about kilometers, some tens of kilometers. That is the radio wave size, I mean the wavelength of radio wave. Owing to its larger size, it is not really useful to understand the characteristics of small objects. In that sense, please understand, radio waves will not be used for identifying the properties of small objects. With this being said, let us see the options. In how many of the above activities can radars be used? Radars, we are using radio waves, that is already established. Tracking the migration of animals. Animals are big objects. As a result, 1 meter to few kilometers, that is the size of the radio wave. As a result, I can understand the presence or absence of the animal. You see, these are the radio waves. Comparable objects in the real life that you experience are given here. So size of a human is also comparable to the wavelength of a radio wave. And that is why you can use the movement of large objects and also animals. That's number one. Monitoring of precipitation. Again, precipitation, large clouds. If I want to understand the constituents of a cloud, I won't be able to do it with radio wave because the constituent of cloud is water molecules in the form of ice, and the composition of that water molecule will not be able to understand, or composition of the clouds will not be able to do with radio waves, but monitoring of precipitation, large mass of water vapor or clouds will be able to, the entire mass, okay, is concentrated in a certain space. As a result, the whole object can be identified using radar, and that is what we do, in fact, in many of the active remote sensing satellites. Monitoring of precipitation is again a right answer. But identification of narcotics, I essentially have to understand the chemical composition of the object, and that will not be able to do with radio waves, and we do it with smaller waves. That is why we don't use radar to do identify narcotics, but you use smaller waves. Smaller waves, visible light can be used. Of course, X-rays are used. You've seen the scanners. In fact, one category of waves, although strictly speaking, they're not radio waves. Okay, some waves between infrared and microwaves. Here, there are what are called as terahertz radiation. Terahertz radiation, as the name suggests, very high energy waves. These waves are used in communication technologies also, but in addition to this, terahertz radiation is used, okay, in the recent times, at least it is being tested in order to identify objects, okay, in the security systems. We are trying to use that, but although there are some concerns that are raised, that terahertz radiation, owing to its small size, you can see it is about to micrometer, and these waves are harmful to bodies because they can penetrate through some of the organs, and as a result, terahertz radiation may be harmful, but at least the studies are going on. But as of now, we do use, in fact, terahertz radiation for in security systems. Okay, so in that sense, this is, I mean, if you want to call these radio waves, it is still fine, because radio waves, the range of waves, please understand. But for radar particularly, we use larger waves because we use radars mostly on a satellite platform. As a result, we don't use smaller waves, because smaller waves coming from a satellite, as you can imagine, can be blocked by the everyday objects. As a result, it makes no sense to use these kind of waves. This is the reason, in fact, okay, the option 1 is incorrect. Okay, or option 1 is incorrect, and therefore the answer is only 2. Fairly easy question, if you understand the basic principle of remote sensing. But please understand, it is all about the interaction of light with the particles, and one of the most important factors, although there are many other factors in the ways in which the light interacts with these particles, but one very important factor is the size of the particle and the size of the wave. If they are comparable, they interact very strongly. Okay, so fairly easy question if you understood the basic principle of remote sensing. And this is one straightforward question. Membrane bioreactors you often hear of in the context of energy production, waste to energy plants, or waste treatment technologies. Not a very difficult question. D is the answer. Membrane bioreactors, as you can imagine, it's a bioreactor, use of microorganisms to break down your hydrocarbons, because essentially what life beings like us also are doing is we are breaking down the hydrocarbons. You eat your carbohydrates, your lipids are essentially hydrocarbons. We are really breaking down the complex process in an organism. Even a microorganism is also breaking them down, releasing carbon dioxide and water. And that is what you do in these membrane bioreactors. Fairly easy question. In addition, one question I want to discuss is 96. 96 talks about use of hydrogels. And there's a lot of confusion about this question. But for me, hydrogels, whenever we look at hydrogen, and material science is another area where civil services, UPSC is focusing in the recent times. Material science has been a focus area for last 4 to 5 years, even before that. Okay, so important biomaterials are also being tested on. And whenever we talk about hydrogels, essentially we talk about hydrogels in the context of being a biomaterial. Please understand, material science is important because in the era of sustainable living, sustainable development goals we have, and sustainable living, because of the harm that anthropogenic changes that we have done to the planet, we are looking for alternatives that can biodegrade, that can be not harmful to the environment, the health of the planet, the health of life on planet, including human beings. So increasingly, we are looking for the sustainable materials which are essentially biodegradable. So we are going away from inorganic to organic. But in addition, even materials that are not harmful to human body. As a result, okay, this biomaterial called hydrogels, okay, which are essentially water. Hydro is water, and you make a gel out of, okay, water is what makes it a gel, and some polymer, whatever you want to use, okay, water plus polymer, that is what makes a hydrogel. They are being increasingly used for delivering drugs, because once you put in a gel inside your body, the gel is biodegradable. I mean, it will evaporate, or it will be used up by body, so not very harmful to the body. So there is no after effect of these drugs that you take. So therefore, okay, this is the context in which we use hydrogels. Hydrogels, as the name suggests, as we have already spoken, it includes it has water as one of its important component. As a result, you cannot use it as industrial lubricants, although there are being experiments that are being conducted in order to develop similar gels for lubricants, okay, alternatives for the lubricants, because lubricants that we mostly use today are hydrocarbons. So I mean, also very heavy hydrocarbons, therefore which is very harmful to the environment. So we are looking for alternatives, but hydrogels cannot be used in the context of industrial lubricants, because it is it's water, and in lubricants are essentially used in order to reduce the friction, and friction produces high temperature, the water will vaporize. As a result, okay, common sense says that industrial lubricants, we don't use it. That is number one. Air conditioning system, we use refrigerants. Hydrogel is not a refrigerant, it cannot carry heat, it does not have the ability to carry heat from, okay, one place to another. As a result, you don't use hydrogels in air conditioning systems. As a result, one only is the answer. There's a lot of confusion about this question, but I'm pretty sure, although hydrogels are being tested, okay, different types of hydrogels that are being developed for industrial lubricants also, but predominantly as of today, when we talk about hydrogels, we talk about it as a biomaterial very specifically. You don't have to know the details, but the moment you hear of hydrogels, you can connect it to a biomaterial and answer this question quite easily. Okay, and in that sense, one only is the right answer. Thank you.